Hi guys! Sequences and series is a lot of information and it's a lot of good math that we will use for other things too. And so I always actually shorten this one anyway, so ha for this year. But we're going to start off with just these arithmetic sequences just like we did before break. These were all nice and simple. An arithmetic sequence is when you have a common difference to get to the next one, which means for that top one, we just add 4 each time, so it's an arithmetic sequence. We say, find the next two terms in this sequence. Show that you add 4, and then you get the next two numbers. Then we add 5, we got 32, and then 37. And so I'm going to go ahead and do one more, and this time the common difference is... So we're going to do actual high school level of math, and then this is when I said about the more math for later. We're going to label these things. The first term we call A sub 1. The common difference, we just use D equals. And we're going to find things like the nth term, and so that's A sub n. I could put A sub 300, that means the 300th term. So, the first thing you need to know is the equation for arithmetic sequences. So, the nice thing with this chapter is it does have a lot of formulas. So we just have to use the formula to find the next thing. Well, in this case, you got to know all the new technical jargon also. So, and then you distribute. If I said, hey, let's find A sub 300, you just plug in 300 for n, and then you simplify. With some of these problems, you might think, like with this one, this is the 12th term I'm going to look for. You might think, well, I'm just going to list them out, that's faster. But the point of this is they're not all simple, and so we do use the formulas for some things. I do need to tell you that an arithmetic sequence is when you add the same number every time. But you can also be adding a negative number. That's okay for the common difference to be negative. So in this case, we subtracted 7. That is an arithmetic sequence. Here, we need to find A sub n first, and then we're going to find A sub 12. So I have A sub n equals A sub 1 plus the quantity n minus 1 times d. Then I distribute and simplify. Equation, or it's the nth term for this arithmetic sequence. I'm going to find the 12th term. I have A sub 1 plus n minus 1, that quantity times d. A sub 12 equals 23. Next, we're going to have geometric sequences. So we're going to multiply by a common ratio to get each next term. So it's easy enough on this one to see, well, here we're just going to take it times 2. 5 times 2 is 10. 10 times 2 is 20. You run into something, especially if you're not sure if it's going to be arithmetic or geometric, what you do is you check. And so we say, well, 10 divided by 5 is 2, and 20 divided by 10 is 2. And so then that's when you find the common ratio. Here, we're going to do 24 divided by 8, and that's going to be 3. And then we're going to do 72 divided by 24, and that's 3. So you take 118,098 divided by 39,366, and you're going to get 3. The tricky part is the bigger number is first, so the common ratio is really 1/3. So you're going to take it times 1/3. And then you take this number times 1/3, and you get this 13,122. So then you take that number times 1/3. You get 4,374. So you take that number times 1/3. And you get 1,458, and so on. For the geometric sequences, you can find the next few terms, or you can find the nth term, or you can find a specific term. Here, we're going to find the nth. We have A sub n equals the A sub 1 times r to the power of n minus 1. So n is the term. A sub 1 is the first term. ratio, and then n is the term. So here, you're done. If we said, hey, let's find the 12th term, you should do your order of operations first. You're going to do 2 to the 11th power and then times 5. The 12th term is 10,000